Welcome back everyone to Data Science for Everyone. Today we're going to be looking at linear mixed effect models with stats models. Let's get started. So first off, let's go on and import in some of our data. And you know what, maybe I'll also give this a bit of a title. So let's do linear mixed effects models. And so we want import numpy. Numpy is np, import pandas is PD, import statsmodels.api as SN, import statsmodels dot formula, statsmodels.formula dot API as SMF. From statsmodels.models.tools .sm exceptions. Still getting used to using kite at the moment. Let's get rid of that. We want to import in here our convergence. Convergence warning, and there's actually needs to be a tools in here. And let's go in and get our data. So data here is going to be sm dot datasets dot get our data sets, and we want the Dietox gpack dot data. And so while this is kind of downloading, again, today we're going to be going over the linear mixed models. And we're going to closely follow an approach from Lindstrom and Bates from '88. Now this is going to be very similar to some of the packages that you would see in R, Stata, and SAS. And again, it's going to be very consistent with those. And the basic techniques are going to be mostly similar in nature, so let's not worry about it too much about that. Now we're going to be looking at the linear mixed models, how they can be fit with the mixed LM procedure in stats models, and the data itself. So let me do something like data head here, and you can see kind of what we're going to be having here. Now what we're going to be doing with this is a longitudinal data, a factorial experiment. Now the outcome of the variable is going to be, the outcome variable is going to be weight here, and the only thing that we're going to be really looking at here is time. This is our predictor variable, that is, okay? And we're first going to fit the model expressing the mean weight, okay? The mean weight here as a linear function of time, and with some random intercept for each pig. And so again, we'll be pulling in some pig here. And then the model specification, we're going to be using the formulas, okay? Hence we imported that in. Again, since the random effect structure is not really going to be specified, we're just going to use the default random effect structure. So let's go on and get that in. So let's do something like, let's actually just do our results here is going to be, let's actually do the model first. Model is going to be something like SMF dot mixed LM. We have weight, we have time. Our data, our groups are going to be data by pig. And then we also want in here our results is going to be something like our model.fit. And here we need to actually state the method. So our method in here is going to be LBFGS. There we go. And then let's also go on and take a look at those. So a couple things that we want to kind of note here, all right? So mixed effects and random effects parameter estimates are going to be shown in a single table, okay? So that's what we're seeing here. The random effects for some animal is going to be labeled this where is it here? Intercept RE. All right, so we have here, we want this particular intercept. And then in stats models, it's going to be kind of above the output. So we have our LM, we have our likelihood, we have our weight, we have our coefficients here. Now we also, so for like this, in the LME4 output, okay, this effect is going to be this pig intercept under the random effects section. So a couple other things that we'll want to look at here. Do we want to do that here? Because we have our group and we have our time. We'll also refactor this here in a second. So now let's actually go on and while there is going to be some good reason to kind of question our utility of using this, we're going to kind of elect to include some standard errors, all right, in the summary table, but we aren't going to necessarily show them with our walled confidence intervals. Now, next, we're going to want to fit a model with 2 random effects. Okay, so let's do for each animal a random intercept and a random slope, and this is going to be with respect to time. So let's see here, model 2. Here is going to be SMF dot mixed linear model, weight, time, data, groups here is going to be pig, and then our RE formula here is going to be tilde time. And you know what, let me zoom out a little bit here so you can see that. There we go. And you know what, maybe let me just do this so I can disappear here for a little bit and you can still just hear my voice. So this means that each pig may have a different baseline weight, so as well as growing at a different rate. So this is going to be a little bit more like a real world scenario. Now the formula is going to specify that time is a covariate with a random coefficient. So by default, the formulas are always going to include an intercept, which can be suppressed if we do something like 0 plus time. Whoops, 0 plus time. This would actually get rid of the intercept, but we're going to keep it in for now. And then we also want in here res2 is equal to model 2 dot fit method is going to be LBFGS, and then we also want to results 2 dot summary. So again, we see here we have everything. Now we can see here that we have this group by time covariance down here. Now this random, we also have again we have our random intercept, okay, and then our random slope. So we can actually do a little bit of a calculation here if we want to, so that again that we can see that they're basically going to be weakly correlated. So let's actually go on and take a look at that. So, you know what? Maybe we won't go into that now because we have here scale. What would we want to do with this?